Hope you guys have enjoyed it all the day. Today, my topic is using SQL Server 2012 window functions to solve common T-SQL challenges. So I hope this presentation will be a delicious entree for your tonight's big feast. Okay, so my name is Steven Wang. I'm a Microsoft certified business intelligence developer, database developer, and a database administrator. I'm senior DBA at Bank of New Zealand, and I am one of the top T-SQL answers at the Microsoft T-SQL forum. I also write blogs at MSBICOE. I also active SQL user group participant, and I also speak at some events. Today, I have a few things to cover. I will first start with a solution comparison by using traditional T-SQL constructs versus using new window functions to answer a very common business requirement. Then I will follow something secret for you. After that, I will talk about the fundamental of the new window functions in the Microsoft SQL Server 2012. As this is a 300-level session, I will not focusing on the very basic of window functions, but rather will stress more on what you should pay attention to and how the new window framing clause works. And after that, this is the most important, the key part of this presentation. I will show you the common business challenges or common T-SQL challenges. Most of them is collected from the T-SQL forum or in the real work. And after that, I will also have a performance comparison between a solution using the set-based subquery and another solution using window function to calculate a very common running totals. So the last agenda of today is actually let our hair down and go down to the wharf to paint the cloud red. Okay? Okay, here I have a very common business requirements. So basically, I have a simple table here. This is deliberately simplified. I have employee ID, I have product ID, and I have period and a sales amount. And we are asked to calculate the 3 months rolling totals. And we also asked to calculate the percentage contribution to the employee sales totals, the percentage contribution to the grand totals, and the running totals. This is very common requirement we will get as you are a SQL developer. So the matrix can be go on and on. But to answer these questions, I believe there are so many ways can be used to achieve the same. However, today I have put together a very commonly used technique for answer these questions. So basically, the idea is like that. We use the common table expression to calculate the employee sales total. And then we use another common table expression to calculate the grand total. After that, we will use the base table to join the employee sales total to get the denominator for the percentage contribution to employee sales total. And we also will use a cross join to the table to get the denominator for percentage contribution to grand total. And as to calculate the rolling 3 months sales amount, which is actually, it's pretty hard to do in the traditional T-SQL environment. So as you can see, what I have done here, I actually used a subquery technique. So basically, we will pass the employee ID and a period from the out query into the inner query. Then to calculate the rolling 3 months sales total. And the same technique will be used to calculate the running total as well. I'm not sure anybody is attending the dev session this afternoon? Not too many. Oh, okay. So they have used another technique to do the things is undocumented update, which is very clever, but sometimes might not be able to get the flexibility in terms if you have lots of partitions kind of thing. So anyway, as you can see, by using this technique, we have used 33 lines of code. Forget about the performance consideration first. This is actually all good. We will get all we want. However, now we have SQL Server 2012. So under the SQL Server 2012, what we can do? So can anybody give me a number or guess how many lines of code are needed if we're using the new window functions to calculate the same based on the same formatting style I had before? 7. How many? 5, 4. Who said 6? Wow. It's a very good guess. All very good. Okay. Okay. So let's have a look. We have a look. Exactly. This is 6 lines of code. Is that true? Yes. As you can, how do we calculate the rolling 3 months amount? We use only 1 line of code. We use only another line of code to calculate the percentage contribution. We use only another line to calculate a running total. And basically, the trick, I believe, is here. As you can see, to calculate a rolling 3 months sales amount total, we used something you might have never seen. It's called rows to preceding. Sounds fancy, is it? Okay. But this is the way you can do under SQL Server 2012. This is simple. This is concise. And to me, this is beautiful. And this is fascinating. I emphasize more how exciting this means to me as I have been used extensively all these new functions to answer questions at the Microsoft MSDN forum, and also used them to solve very complex business logics. I hope you guys also get excited as what I feel. Have you guys got excited? Yes. Oh, that's good. Great. That's great. So it seems you guys is very responsive and supportive. I think I needed to do something. So what are we going to do? Before that, there's somebody is answered the question correctly. I think he deserves something. Okay, so I'm not a good thrower, so if it's not raining properly, somebody pass to him. Oh, that's a good catch. Thank you. Okay, so for next couple of slides, what I'm going to do, I have some questions here. And if you answer it correctly, certainly you will get something. I have a few things here, memory stick, something here, and all sorts of things. The rule is nobody can leave now before I give out all of these things, okay? The first one, as you can see, this is a very simple table I used before. So only have 4 columns. So the first question is, select dense rank over partition by, order by, blah, blah, blah. So starting from which version of SQL Server would this query be valid? Okay, who said 2005? I think I saw that gentleman start first. So, okay. So, the answer yes, it's indeed 2005. So, thank you. Seems it's very simple. It seems you guys all know it very well. Okay? I think you need to be a little bit harder then. So, next question. I have this one. Select the employee ID count distinct product ID over partition by employee ID order by period from the table. So starting from which version of SQL Server will this query be valid? Who? 12. 8. Any other number? 5. Who said that? You said wrong answers. Why is wrong answers? Wrong syntax. Pardon? Just a guess. Okay. So. Okay. Carry on this. So I will take. Nobody answered this question. So the answer is wrong syntax. So this is very important. You need to know window function didn't take distinct keyword. That is very important to know. So every people like to count distinct something to do something. That is not allowed. Okay? I passed this message to you guys. This is very important. So next question. I have select employee ID, period amount, last value. Amount over partition by. So same question. Which is the correct answer? 12. Okay, that lady answered the same. Yes, certainly it is 12. So, okay, do you want evaluation copy or you want a mouse? Okay, that's okay. Sorry, I should calm down. To be nice to ladies, okay? So, for question, I have this one. So this question is, for this query, which the following results is correct? Pay attention to just the last column. B. A. Who said B? Who said A? Oh, I nearly running out of things. Okay. Okay. The answer is A. So before that, I have some very fancy. I have a Hoyt's movie voucher here. So I hope to. Can anybody? Okay, I can give you it later. Okay. So. This is very tricky. You may wonder, you do expect the results will come back as B. So how come it will be A? If this is A, this sounds useless, right? So the trick here is, as you can notice here, we got order by, but we don't have frame clause. So when the frame clause is not included, it's basically is only will calculate the last rows from the very beginning to itself. So that's why in the first answer is always it's itself. I will cover a little very detailed in the next couple of slides. Okay, that's good. Which is actually finished our question session. So it's all very good. Okay, so now I want to cover the fundamental of new window functions. I have 5 areas to cover. So what is a window function? Actually, back to a year ago when I trying the Denali version, I put through the window function, actually come window function, Windows function altogether. But confused with window function with Windows function. I did a test again last night. There's no more Windows function coming off in the Google, so which is good. So a window function is basically a window is a set of rows. So window functions is truly uses set-based thinking. So it's not a cursor or a procedural thinking. It's a set. So a window function is a function applies to a set of rows. I actually tried to find a good definition in a book online, but unfortunately, I couldn't find a very easy to understand one. However, I come across this one from the PostgreSQL documentation. But basically, the concept is the same. So it says a window function performs a calculation across a set of table rows that are somehow related to the current row. I found this one is easy to understand. So this definition is come from book online. So in SQL Server, all window functions use a over clause. The over clause actually defines the window specification for the function with respect to the current row. So the concept is, this possibly is a little bit boring because, as I said, this is 300 level and we're talking about the only window function. We need to go down a little bit deep. So over clause is define window specifications. I will give examples later. So now I try to talk about the adoption of window functions in SQL Server. So basically, the window function was introduced in ISO and the SQL Standard 2003. In the ISO SQL Standard 2006, there is no changes for the window functions. In the SQL Standard 2008, this window functions are enhanced and some new functionalities added in. So the latest standard is 2011. It's just last year. There are a very rich and extensive coverage on window functions. So we can see from this standard trend, the window function is increasingly become more and more important and to be first. So it will be a future of the T-SQLing. So Microsoft SQL Server pretty much window function adoption pretty much in line with the SQL Standard document release. So in SQL Server 2005, window function is introduced. So the over clause is introduced with limited functionality. In SQL Server 2008, actually nothing is new. It's exactly the same as SQL Server 2005. In the latest release, 2012, the extended support on over clause is implemented. And we also introduced 4 new distribution functions and 4 new offset functions. What is version next? I don't know. Is there Microsoft people here? So, okay. So, but I will believe in the next release there will much richer support on the window function will be implemented. So, in SQL Standard we have 4 different categories. Aggregation functions, which is exactly the same as the aggregation function we normally use. Sum, count, average, min, max, all these functions. Rank functions. This one, I have to ask a question. but this is no price, okay? Has anybody here never used the row number function? Great, nobody. This means all you guys know this quite well. So rank function is very popular, is commonly used. So certainly it covers 4 functions: row number, entire, rank, and dense rank. These 4 functions is fully supported since SQL Server 2005. Now we have introduced new functions called distribution functions. So distribution functions also have 4 functions. It's called percent rank, cum dist, percentile count, and percentile disk. Because I'm not, as I said, not talk very basic, what's the name, it's easy for you to do a research, go to book online to find it. So I just briefly took what is inside. Offset function. Offset function is very, very useful. Is anybody here is also an MDX developer? 1, 2, 3. Okay, that's good. If you are an MDX developer, you will find this is so easy for you to do what is opening balance, what is closing balance. However, this is a tedious job for a TSQL developer to find the opening balance, closing balance. But now, this is no longer the case. Because we have introduced 4 new offset functions: first value, last value, lead, lag. So this 4 function is pretty much very similar to what the MDX function are. And I have to mention, under the hood, this is really only 2 functions implemented. It's first value and the last value. So lag and the lead, during the execution time, it will indeed expanded to last value. So only first value and the last value is truly used by the SQL engine. So, but in SQL Server, book online, the distribution function and offset function are actually combined together, called analytical functions. So if you go to book online, there's no such thing, distribute and offset. But to me, chapter 4 is a little bit more intuitive. The element of the window functions. As we know, all window functions should have a clause called over clause. So you remember, over clause is a key. Over clause has 3 different elements. Partition by. Partition by is indeed optional. It is optional because if the partition by is not included, it will regard the whole set of row or whole table or whole query results as a partition. So over clause also have an order by clause. And we'll have a frame clause. With order by clause and the frame clause, actually, for the aggregation functions, is just implemented in the SQL Server 2012. And not all of the window function can support all these 3 elements. So aggregation can, and the first value and the last value can support, but other functions maybe not support all of them. So a typical example of window functions looks like that. So some amount over, partition by employee ID, order by period, rows between unbounded preceding and the 2 following. So it's very fancy things. Okay, so basically the frame, the rows always use the between, and it covers a consecutive range. So it's always from something to something. You can be, so unbounded preceding means from very beginning. You can go down to unbounded following. That means goes to the very bottom. And the 2 following means for the current row, I will go 2 rows further. So you can say I goes to 4 preceding and 2 preceding, and 2 following and 6 following. That's all is allowed. So the frame clause this is very new. So this is very important. I need to talk is frame clause is about the rows and the range. So you can use 2 keywords, either rows or range. By default, as last value we use, by default the range will be used. When the range is used, it's always range between unbounded preceding and the current row, because the range is not fully supported by SQL Server 2012. So the most obvious rows and range, there's some difference. Is the range actually has a tie in it. The tie is based on the order by clause. If your order by come back with some same values, the range will put them together. Window spool operator. This is very important. Window spool operator is introduced during the query optimization stage. So if you try to use SSMS 2008 to run 2012 queries, normally you are okay. But if you use window function trying to see the execution plan, it will come back error, because the window spool is not implemented in the older versions. So the window spool is very important if you try to do the query optimization by using window functions. Behind the scene, window spool used either in memory or on disk work table to do the frame data processing. So as you can imagine, in memory will certainly be much faster. So our goal is to try to come up with something to push the query processor to use in memory as far as we can. So I have to mention, if the range is used, or you don't specifically put the rows into the frame clause, the query processor will always use on-disk work table, so which means will be the performance penalty on that. So this is a good reason for us to not use range keyword if you can. So let's look at a typical example here. So that's the partition by, order by, and the rows unbounded preceding and the 2 following. So I will give some visualization looks like that. So partition by, so as you can see, employee ID, they partitioned together, and the order by, the period column. And for each rows, it will have a frame. So the first row is a frame from unbounded preceding to 2 following. So that's a frame. To second row is like that. As you can see, for very bold rows, there's really no 2 following, so it stops at itself. Okay? Restrictions. I actually very surprised when I was answering questions at the MDSN forum. There so many developers is very confused with the order of logical query processing. I'm not sure. So it's basically logically. So a query starts from clause. Then inside the from clause we can have inner join, cross apply, unpivot, pivot. All these things will be logically processed first, then goes to where. Because a lot of people think the where will process first. But logically it is not. But physically, it might be, but we don't talk about it physically. So group by, then goes to having, then goes to select, then goes to order by. And under order by, so we can have top, or the newest function offset fetch is also is after order by, and if you use XML features, full XML will be under order by. But the important things I want to focus on is window function can only appear at select and order by clause. This is very important, needed to remember, as anybody come from the Oracle's background. Oh, good. In Oracle, you can use, say, where low num less than, say, 10. So in SQL, you cannot say where low number, blah, 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 less than 10. That is not allowed because it is not in select or order clause. So you normally need to work around by use a common table expression. So yes, you need to specifically remember this. For the aggregation function, basically we have actually all aggregation can take two keywords. You may never use one keyword called all. You probably use a distinct because all by default it's all. So as I have mentioned before, when you use the aggregation with over clause become a window function, distinct is not allowed. Okay, there are a few more other restrictions, like you cannot nest the window functions, and the lows frame cannot take negative values. This is different with the MDX, like you can the lead -6 or comes. No, you are not allowed in the SQL Server. Okay, I have another question to answer, to ask. So I have two queries here. So the top one is pay attention to the max amount over blah blah group by employee ID, product ID. The second one is max amount over partition by group by employee ID. Which is valid? Who said A? Who said B? B. Or both? C. Okay, fair enough. Who said B? The answer indeed is B. So this is very important concept. You really need to pay attention to. As we said, the window function, when the max used over clause, it's become a window function. So window function is not aggregation function, it's aggregation window function, but it's still window function. So you see, so first query, you take group by employee ID, product ID. Then the amount inside, there is no aggregation of the amount. And it is also not in group by clause. That make it is invalid. It's not allowed. It's tricky, is it? But really, this is a very tricky one. So the answer is indeed is 2. Okay, now the most exciting part of this presentation is called the common TSQL challenges. The first one I said filling null values with preceding non-null value. So what is that? That means we normally have something in the table with values and followed by a bunch of null values, and another value followed by another bunch of null values. So you need to fill up these null values based on the previous value. Have anybody had such problem? Good. There's somebody. Okay. Also, we always ask to calculate the period to data aggregation. I know this MDX guy may be laughing. Oh, this is so easy. But it's not so easy in TSQL. Running and sliding aggregation, as we mentioned, actually, I was always surprised why TSQL has so hard to do the running total. Obviously, now it's no longer the case. Identifying gaps and islands. This is my favorite one. And this is the most commonly asked questions. Have anybody had such problem? Gap and island? Oh, good. Yeah, there's a few hands. Actually, I was recently invited by Microsoft SQL team, somebody to contribute to a series of blogs. So this one article is just published yesterday. It's called T-SQL Do in Your Own Way. So it's very intensive covering on the gaps and errands. If you're interested, you might have a search, you can see that. Then we have calculated median value. This is also another challenge. Anybody found it's calculating median value? Yes, there's something. Oh, max concurrent intervals is always people log into sessions, lots of people log into sessions, log out and log in. You try to find what is maximum number, and identifying overlaps, deduplicating data, and another thing is to compute the data called a Pareto chart, trying to do the plotting. And this list can be on and on and on. And the thing is, I have to stop here and get the hands dirty to do some demonstration here, okay? Oops. Me? Sorry, how can, which one is this the answer? Oh, okay. Oh, it's getting into sleep. Okay. Okay, the first question. I actually take the questions from the T-SQL forum. So I try to see, is the internet still working? Okay, good. So the questions looks like that. I just big it. And it says, can you guys see it? Okay, good. So does anybody have any ideas on how can I do this? This is he's mocked up with a spreadsheet. It says he's ordered the days in the descending order, and the first value is group 1, and some blanks, and some 1, and something, and he wants to be in the left, right. I'm confused. this side. Okay. So the thing is, this is actually called a problem called relational division. Some sorts of like that. It's a relational object like in T-SQL is actually pretty hard. So I give you 10 seconds to think. If you asked to solve this problem, what technique will you use? Okay, so what I think idea is if we can put the top one and the following blank values into the same group, then life will be much easier. Is that right? And how can we put into the same group for this the top one and the second one into different same group? Oh, you might think, oh, okay, we can use recursive common table explanation. That's all very good. However, you pay attention to there, indeed the data is not consecutive. There's some gap inside. So if this turns into a real solution, what you need first to do, I just try to see, can you see that? You need to put all the record in a consecutive ID. So that's what's called row number. We use a row number to order by descending to get a series of consecutive rows. Then what we needed to do, I tried to do to find out the group is not null, because this I want to compute this recursive table. So I would get the group is not null from the first common table expression, then to join back to the first one, because you can, with a low num equals to another low num plus 1. Giving that the A group is null. So at the end, because this will put everything into the same group, then we use a dense length to get what results we asked for. So I can just show you, okay, maybe. Can show you that? So as you can see, this is what we come up, right? So this is a normal way, as I said, a normal way. But now we are in SQL Server 2012. What we can do? I bet you will laugh. This is what we can do. I used to say I get date, account group, order by date, descending lows, unbounded precedence. That's it. So if I run this query, it's exactly come back with the same thing. Do you feel this is good? This to me is marvelous. Actually, based on this technique is really, you cannot see anywhere possibly because it's pretty new things. And based on that, we can solve lots of business problems. So I give you another example here. This is what is, as we commonly receive Excel workbook as data source. So Excel workbook, because in Excel, people it's very easy to do the merge. You may get the data from the OLAP system. So somehow like a product is grouped together and the first row is got a name and the current following is now. So you import this data into the SQL server and this will become, I just show you, I already imported it. Okay, as you can see, this is some null values inside. So you were asked to do something. It's basically filling in these null values in the real world. So, okay, so what we can do this. Okay, so the best of the concept, also the technical we learned from the previous one. We used just count. So what I did is I imported this data from that table because I don't want to disrupt that table for now. And I use this. As you can see, I get the null values, but I have my group. As you can see, my group is for now is indeed everything in the different group. You see the first, each different product in the different group ID now, right? Because we got different group, so then life will be much easier. What we can do, now we have new functions called first value. So we can, based on that group, we just grab the first one. So I use another common table expression said I get the first value based on the previous, the first value, okay? Then I update that common table expression for the product with the new product. I try to did I drop? Oh, sorry. I did drop that. Oops. Oh, what I did is I deleted something. So I deleted the first topic. So this will come up, put everything together. Maybe, how can I? Okay, here you see. Yeah, this is what we get out. So based on that technique, okay? Okay, so the next one, we try to do the period to date. As commonly we have a sales table. You ask to calculate the month to date, quarter to date, year to date. So how can we do? We normally use the subquery. But when you use window function, it's easy because as every data warehouse is supposed to have a calendar dimension table. A calendar dimension table normally is conformed, so you have lots of attributes. So you can month, quarter, year, all as attributes. So when you get a sales table, you join to the calendar table. Then you use this magic partition by. If you partition by months, the product key, year, month, it will get back the month to date value. If you group by the quarter, then you get the because this is running total, okay? You will get the quarter to date value. And if you get into the year, basically it will get a year to date value. So this is how you calculate the month to date values. So I just try to run, see if yes, as you can see, this is get back the quarter to date, all these values. Trying to find some gap, islands. What does islands mean? We have a series of number values, 1, 2, 3, 4, 7, 8, 9. So in this series of 9, 1, 2, 3, 4 is actually in a consecutive range. But from 5 is missing, 6 is missing. So your task is to find what is the range is actually in the same range. So the technique to use is what we used to use a. This is a very useful technique. You use a number to minus dense rank over. This calculation will put every consecutive numbers into same group. But if there is a gap, then the group number will be changed. This is because, as you can imagine, if consecutive is always increase 1, and the dense rank based on that is also will always increase 1. So because the increasing pace is same, if it's consecutive, this is always, or minus value come back is always the same. So I'm just trying to run that. As you can see, this is what we, oh God, sorry, I just put it here. This is what we get back the range data. So 1, 2, 4, 6. This we put everything in range. As you can see, the example is 1, 2, 4, 5. So this is the technical. So again, in the real life, this will be much harder for you to do the things. So if you can see, you normally will get is not just one value. Always we give you a range. So that is from the 2 to 6, 7 to 12, 13 to 29. Sorry. Okay, that's good. So this is a little harder for you to try to find out what is which all you need to compact all the range together. So how can you do that? So this is what we says. I used another. Is again we used we call lag function. So we try to. What does lag do? Lag is good trying to find the previous value. So because we have like for this particular low 7, if we lag the last end value that is 6, to put it there, then we can do some calculation. So basically the idea is we try to calculate if it's consecutive, we will put it as 0, and if we it's quite hard maybe if to explain because 0 is a magic number. So possibly I will show you what does this do, then you can understand a little more what it's doing here. You see, this is the comeback. So pay attention to these values, like 2 to 6. And 7 to 12, all you need the change is 0. So you can see all 0, top zeros in the same range. And then you go to a 1, and then go to a 0. So how can we put these two lows, this low and this low, into the same group? The idea is we can use running totals. So if say we put a running total based on your change, every consecutive range will be in the different group. So that's is the whole idea comes from. So, okay, I try to run the whole thing. This is what we come back. Okay, so I have so many queries here trying to demonstration, but I think I have run out of time. And actually, I have here is a very fancy one. Actually, this is called where is it? Trying to think. Oh, T-SQL Challenge 79. This is actually, T-SQL Challenge is a committee in the whole world. You can participate in that. It's very, normally it's very hard problems, puzzles. So this puzzle, when it comes to using window functions, as to me, become a piece of cake. So, but I cannot demonstrate here because it seems piece of cake, then it's quite a few rows. I have to move on next topic, okay? So, now, as I said, now we move to the performance comparison. So you see, okay, that's good. You have seen some cool techniques we can use to calculate some very complex business logics. Then you may think, yeah, this looks good, but how does the performance looks like? Is the performance good? We're going to test it, okay? So I have set up a scenario here. I use a traditional set-based subquery to calculate the running total, and I use another, it's called window functions, to calculate running total. So this is two queries I'm used. So the scenario I will set up is I will first calculate 10,000 rows for each. I will get an execution time and put it into table, and I increase the rows to add another 10,000 rows and add another 10,000 rows until 100,000 rows. In that case, we can create 10 points. So then we can compare. But I'll roughly give you an idea how this looks like. Performance comparison is okay. So this is a traditional one. So what I'm trying to show you is if it's only 1,000 rows, use traditional one. Oh, sorry, this is a long database, I believe. Okay, quick. It's pretty quick. However, as I said, this table, I got 100,000 rows. So what we can do? So I just trying to show you if I run this query. My computer's got 8 CPU on it. So I just show you something. What? What you can see, all 8 CPU is maxed out by running this thing. And this takes ages to again and again. So I think it's time I can stop it now because I really don't want it to take too long time to do. Okay, so I stop this query. Where is it? Oh, 33. Okay, so that's good. At least it's come back 33. But I will show you if we use the window function to do the same thing. Ooh. Can you imagine? This is the difference. Okay, so I can't to run the whole thing because it's taken too long. So I already clicked these 10 points for you. I plot the chart like that. As you can see, from the rows increasing 10,000 rows to 100,000, the subquery execution time increased exponentially, but the window function is only increasing as a linear fashion. Okay, so now it's the time to come to conclusion. As I didn't actually don't have too much time to give you the demonstration. It may take me a couple of hours to fully demonstrate lots of things and to you. But to me, the window function is fun. The window function is elegant. The window function is very efficient. A solution by using window function is normally outperform a solution by using the traditional T-SQLs. And the window functions use the set-based thinking. This is very good for a new programmer, a new T-SQL programmer, or somebody from the programming side to think the T-SQL is a set-based theory. So when I started as a programmer, I started from years ago as a VB programmer. I found T-SQL is so easy to do. Everything I can calculate. I use cursor, get everything. Only until when I get into the data warehouse, then the loads come by millions and millions. Then found out all my code is become shit. It's just this is what I experienced. Okay, so the last but not least, to me, the window function is the query returned by this one. I deliberately make it looks difficult. I've put some new functions there. I use reverse concat something together and order by offset loads fetched by first row only, something like that. How do you guess what this will come back? Wow, awesome. Someone didn't know that. To me, window function is phantasmagorical. It's truly. So, what do we do next? Upgrade to SQL Server 2012. Okay, I have a couple people to thank. First of all, I will thank to MVP Isaac Bengen, and he's very generous, and I used some code from his book. He's wrote lots of T-SQL book. He's basically the very respected T-SQL guru in the world. And I also would thanks to MVP Peter Larsen. He actually, we had lots of discussion, and he gave lots of suggestions to me. And by the way, both two guys are not in New Zealand. And okay, so I hope you guys have enjoyed this presentation. Even I see people leaving. And okay, that's good. Truly, if this presentation has intrigued your interest and curiosity to do more study on window function, it will be very good. And if you want to contact me, you can email me at steven1@msbicoe.com. You can search the link in. I do have Twitter. I only have one follower, which is my wife. I write a blog at msbicoe.com. By the way, for these people found MSBICOE not easy to remember, it stands for Microsoft Business Intelligence Center of Excellence. By the way, Anna is here. This has nothing to do with Microsoft. Okay, so the last one is if I would really appreciate if you can do the evaluation for this session, and certainly you will get some instant prize. So this is pretty much covers my presentation for the day. And thank you so much. And now I'm hungry. I need to go to the club. Thanks.